Good afternoon and welcome to the Blind Tinkerer's Workshop. I'm going to be doing a little project today. Now, a lot of you, like myself, throughout all the years, I'm sure, have discharged electrolytic capacitors with simply taking a screwdriver and just zapping them out. Well, that's all well and good for the most part, except it probably doesn't do the capacitor any good. It usually destroys part of your screwdriver and even the leads on the capacitor or the terminals on the capacitor, depends on how much current it's involved in there. Now, I'm going to throw together something. It's not much. I don't have very much material to work with as far as making a case for it. But what materials I have, basically you can use just about anything, from simply using clip leads, but these are small, but I've used them, and a resistor. The resistor don't have to be any special value. In this case, I got an old, it looks like a 5-watt, 1200 ohm resistor. I've used 2000 ohm resistors. I've used 500 ohms. Basically, what you want to do is to have some kind of an current absorption there when you are discharging your capacitor. Like here is a 250 volt electrolytic, and I've got a bunch of these capacitors in, and what I usually do is take them and put them on the ICO. Right now the ICO is not on, but what I usually do is to form them up, especially if they've been sitting for a while, and I bring the voltage up very slowly with a voltmeter across the terminals here at the same time. And if it's a 250 volt capacitor, I'll watch the needle start at 0. Of course, this puts out 39 volts, even though it's all turned all the way down, but that's not a problem. We don't go by the scale anyways. So I watch the meter as I'm cranking this up. What I'll usually do is from time to time I'll take the capacitor off the test leads and watch the voltmeter, which is still connected here. And verify that I'm not putting too much voltage in. I start low. Okay, so anyways, you all know this. You know, you slowly bring the voltage up, you watch the eye, and you know the routine. And until you get to the rated voltage, which I usually do about 5 volts under, sometimes 10 volts under. If it's 250 volts, I'll do 240. But the point is, when you're all done doing this, you do not want to go boom like that. That's how these controls get burned out. I've told you this before. What you do is you leave this alone. You unhook your capacitor from the voltage source. Now, like myself, and I'm guilty of doing this, you take the capacitor, and in this case, I'll take it and I'll bring it down to some metal object and go bang like that, and it makes a pit in the metal. It even did it here a little bit on the scope frame. It's not probably good for the capacitor, and it certainly isn't good for your screwdriver if you're using it, if you're doing it in circuit or something. So what you want to do is to make yourself that's a coil. That's got to be put away. A power resistor, 2 watts are fine. 2 to 5 watts, 10. It all depends on how large of a capacity you're discharging. When you're using 1,000 to 2,000 ohm resistor, you won't even see a spark on the leads. Okay? So what I'm going to do here is I'm going to make this so that it's going to consist of, this is a clip lead I had laying around with a wire already on it. This here is one of these cheap Harbor Freight, these meters here, which the leads are always the worst leads out there, the thin wire. Okay, what I had done is I took a pair of pliers and I pulled out. Let me put you on a tripod and I can show you better. I don't like handheld unless I really need to do this. Okay. What I did is I took a pair of pliers and this is wedged in here. And the original wire, which was in here, is right here. It's very thin, not even soldered. It's pushed up in there. And you can't take this probe apart. But I figured I'm going to sacrifice this because it's no good anyways. I mean, these leads are always breaking off inside. So this will make a good probe for me. But I can't use this tip because there's no way I can solder that on. It wedges in there really hard. So instead, I took some, I think it's 20 gauge wire. I had some 20 gauge wire here, okay? And I stripped it back about 3/4 of an inch, almost an inch, and I tinned it with some solder. So now what you do is you just push this in here, and you work it through till it comes through here. Now, being that it's tinned with solder, it's a little more rigid. Mind you, this is only the end that you're going to touch the capacitor with. The other end is going to have this clip. This isn't exactly the kind of clip I really want to use, but I don't want to use one of my good Muller clips that was given to me because I need those for regular test leads. So I could use one of these cheap things here. And I might even do that. I might sacrifice one of these cords. As a matter of fact, I got one hanging up that the end come off of. I'll do that instead of using this. All right. So what's going to happen is this is going to be put in here. Okay. I'll probably use some hot glue or something and keep this from pulling out. Or I might put some epoxy in there or whatever. This, if you don't press down too hard, this will be very good for touching the capacitor, like this. All right, here is a real crappy, this is the old Radio Shack. These are thinner than the Harbor Freight. These are the Harbor Freight ones, here. You can see the difference in the wires. This is the ones I had back in the 70s. So these are always coming off. So what I'm simply going to do is I'm going to use this clip and put on a heavier wire like I did here. This is not the Harbor Freight wire that came out of here. I'm off camera again as always. That's nothing new. So let me show you what we're going to do here. We got a 1200 ohm resistor. This is just a resistor I had in my junk box. What we're going to do is strip this end here. I can't see the viewfinder. I can't stay. I'm sitting down. It's very difficult for me to see the viewfinder on the camera. I think I'm in view. I'm going to strip this. I'm going to solder this to here. Okay, and the other end will have a wire on it. It'll come out here. And then I'm going to take and tape it up, and then I'm going to put some heat shrink in there, and it'll all be sealed up. And it'll be nothing fancy. It's just going to be something to discharge the capacitor. So what I'm going to do now, stop talking and let's get going on this. Okay, One thing I liked about these old Radio Shack ones is the clips don't, the rubber cover don't roll inside, slide inside. Like this here, they're always sliding. When you grip on it, it slips over like that, you know, and it's terrible. The old Radio Shack ones never did that, but they're also smaller than the Harbor Freight, and the wire is super thin. So I got a piece of, this is I think 20 gauge. So we're going to put the thing through the hole here, and it fits very tight. Very tight. So you can tell the original wire was super thin. This is the original wire that was on the Radio Shack one. You can see how super thin that is. I mean, I can just take and break it right off. It's junk. So now what we're going to do here is we're going to solder this onto the onto this clip, which is, I'm going to get my hemostat out.
Actually, I don't even need that. I think I can use these pliers. We'll get the soldering iron going here. And see if I can. I lost my magnifying glass. There's nothing new. Here it is. I don't even know if I'm in camera or not. And we gotta pin this. Pretty bad. I can't even see if the solder's on the top of the wire or on the bottom. I'm probably off camera. But that's nothing new. That's nothing new. And it's supposed to be over here. I can see it now. Let's see. Can you see that? I don't even...
Oh. Can you see that? That's the good question here. Can you see it? I can't. I can't seem to get the hemostat to hold right. I could use the hands-free thing I got from Harbor Freight. It looks like I'm on there. It looks like I'm on there. Neatness is something I can't be anymore. No way, Jose. No way. Now we got to get this up in there. We open the thing so I can slide this over. You want to have an insulated clip so you don't get zapped in case you don't have both leads on the capacitor, and this isn't going to cooperate with me here. This boot is old and it doesn't like to slide. I wish the newer ones were like that. Okay, all right, so there we are. There we are, folks. We've got that end made up. Let's shut this iron off. I don't like leaving my soldering station on too long. I shut them down and then turn them back on again. And I tin the iron before putting it in the holder. Okay, okay, so what we've got here is essentially the resistor goes between here, nothing complicated, but we want the leads to be long enough to reach wherever we're reaching. In this case, we don't need those long leads for discharging a capacitor here, but you do want it for working in the chassis and discharging. Okay, now what we got to do now is Two things. First, we got to put a small piece of heat shrink on each piece here, which will cover the leads after I solder them. Again, I'm off camera. I'm sorry, I can't see the viewfinder. I'm about 8 inches away from the viewfinder, and because of the angle I'm working at. So if I'm not in camera, I apologize. There's nothing much I can do about that. I can edit out a lot of stuff, so you'll notice that in a lot of my videos they seem to jump. It's because I edit out certain things. Sometimes it's long-winded. That's mostly the reason. Anyways, we want to put a small piece of heat shrink on this wire here and push it down and out of the way, and another small piece on this one and push it down and out of the way. And then we want another piece of heat shrink which will fit over the top of this resistor. And then maybe even another one to go over the whole works, but I don't think so, because I'm not going to be able to shrink down a real big piece of heat shrink onto these ends of the wire here. So I'm going to try it with just 3 pieces of the heat shrink, and I'll probably end up wrapping electrical tape around it. I'm going to do all my soldering and then putting this together. When I'm ready for the heat shrink, I'll show you what I'm going to do with this. Alright, I got one piece of heat shrink in here. That worked out good. I think I got it. Yeah. Sometimes it gets so difficult that I have to carry the solder onto the soldering iron and carry it over to the wire. Especially when I'm working in tight quarters, but here I didn't have to do that. So now we've got another piece of, well, we had a piece of heat shrink, but it fell off. But not a problem, we can slide it right over here. So that goes, make sure that's cooled down. We don't want it to lock into place just yet. Okay, so that's how we're going to do that. And I could get the heat gun out, but this is quicker. Okay, now what I got is a white, happens to be a white piece of heat shrink. That's going to go over the whole thing, and it's not long enough, damn it. But actually it won't shrink down, only on the resistor. So what we got to do, let's turn the soldering iron off first of all. We got to heat that up. Damn thing keeps going out on me. Okay. All right, now what we do here, I hope I'm in camera. I turned the camera around so I can't even see the viewfinder at all now. And put that in here like that. So what we essentially have is this. This will clip on to the ground of the chassis you're working on. It just happens to be red. It's no big deal. Actually, it's easier to find when it's hanging up in the shop. Or this could be connected to one side of the capacitor, and this would be the other side where you discharge it. Okay, so now what I got to do is to get this to stay in there. And I guess I could put some epoxy in there. So I'm going to probably have to maybe what I'll do is I'll wrap this all with tape right here, from here to here, and then I'll get a big piece of heat shrink. It'll fit right over either one of these ends here. Slide it over and heat shrink it down over the top of this. We'll do that off camera and experiment with the size of heat shrink. I got some bigger heat shrink than this. I just realized my camera was not set on macro, so I have no idea how this is going to come out. What I did is when I clip capacitors off and stuff like that and resistors, when I hook and pinch, I always have new leads left over. I save these. What I did is it was a little difficult, but I managed to do it, and I'm off camera again, is I wrapped it around the tinned wire that come out of here. I wrapped it around so now it won't pull out. So now I'm going to put some solder on that. So that'll make that tip even more firmer than it was before. So we're going to do that right now with the iron. The iron is ready to go. We're going to solder on that. We'll get that so it'll never come out of there. So if you look closely, you may see a little tail of wire sticking out on this. Maybe you won't see it. Let me see if I can get you a better view here. Alright, there's the tail right there. See that little tail sticking out right there? I purposely left that there so it acts as a stop so it can't be pulled out again. Now this tip is really firm. Unless you press real hard, you're not going to bend that. Okay? This is what we call the old blind tinkering goat Rube Goldberg capacitor discharge thingamajig. I don't know what you're supposed to call it. Alright, now we got to get a piece of heat shrink that's going to fit over this. But first I'm going to tape this up so I'll have something for the heat shrink to bind onto, because we don't want it to be loose and fall off. So I'm going to try to wind enough tape on here so it'll cover up the green here, it'll cover up the green here. Build it up so it's straight across as much as I can. And then slide a piece of heat shrink over it. So I got to check my heat shrink inventory because I don't want to have it too big here because I may not have a piece that'll slip over it. So I'm going to be doing that off camera, and then we're ready to try this thing out. Okay, I'm sure I'm on macro. I think some of these videos may be out of focus because I didn't set the camera on macro. It's on macro now. You can see that I built up these two ends so it'll be even with this, so that when this is shrunk down, it should just be about right. I have to trim this a little bit here. Not going to be perfect, but so I'm going to go doing that now. I'm going to try this on and see how much clearance there is. I want to make sure that when this goes on, it's going to shrink down good. So I might just put one layer from here to here of tape, and then that should fit on nice and snug, because when this shrinks down, I want it to be nice and tight on there. I don't want any looseness at all. Okay, it's 1200 ohms. So now we're going to try it out. It's not the neatest job, but it's functionable. Okay, I've got a 47 microfarad 450 volt capacitor on the ICO bridge. I have the control all the way down, but like I said, I can't even talk today. Like I said. You got to make fun of yourself sometimes, you know. Anyways, it's 40 volts all the way down, but I'm not going to worry about that. We're going to bring up the voltage. These capacitors are already formed up. I just want to demonstrate Okay, we're charging 270 volts. And the eye is fully open. Eye is fully open. We're not going to go to full voltage because I want to give you a demonstration here of the capacitor and discharging. Now, like I say, you never drop this down with that capacitor on there when you're doing the leakage test, because that will damage this control. So we're going to take off the lead off the capacitor here. The voltage is 358 volts. I'm going to take off the lead. One lead. It went up to 360, so I mean basically it's fully charged. What you don't want to do, and this is charged up now. Let's see, where can I discharge it? Let's discharge it right here. You don't want to do this. Okay? That does a number on the leads and it does a number on your screwdriver, whatever. Now let's do the same thing with my little rig here. Alright, once again I got the capacitor hooked up. These are already been checked out and they're all formed up anyways, and they're all stuff from Sal's Capacitor Corner, or some of my viewers have sent me in some capacitors too. So we're going to discharge it now through the rig here. So in order to do that, I got to put you back on the tripod again. Now you can't see what I'm doing, but I am disconnecting the capacitor from the capacitor bridge. Now I'm dropping the voltage down to 0 on the capacitor bridge. This capacitor is fully charged. It don't matter what lead you use. You probably won't even see a spark on this. Okay. Now, let's take a screwdriver. Nothing. It's totally discharged. 2,100 ohms, but I would say anything in that range. I mean 1,200 ohms, I'm sorry. But I've used 2,000 ohms, it works just as well. So anything in the 1 to 2,000 ohm range. Now, naturally, if you got 500 volts on a large capacitor, you may want to go to a 10 watt or something like that. But this is just a brief discharge, so it's not going to really generate that much heat. But you can see the size of the resistor I put in here. I'm estimating about 5 watts. 3 at the very least. And that's all it is to it. That's all there is to it. So, out of junk box materials, discharge your capacitors safely. Thank you for watching. You have a good day.